Warning, flashing lights. Thanks for watching. Try out the system yourself. It's on the workshop. Welcome back, everyone. We are going to be continuing the Universe Sandbox 2 project I was working on last video, where we are making an entire original solar system around Stevenson 218. So far, we have 4 out of the 10 planets done. This one, the hot planet. Then we have the warm planet. Then the lukewarm planet. Then the nice planet. Now, we have 4 planets achieved, so I'm planning to switch to, maybe adding something a bit more, unique. We are going to be adding hopefully anyway, I'm going to try and add an asteroid belt around Stevenson 218, much like the one around our solar system. So, eyeing up everything I should use. I think that Phobos and Deimos are going to be good objects to make up the majority. Well, actually, Stevenson 218. I really wish it would let you know where it would go. Never mind, that would probably... So, the best bet's definitely going to be making this by hand. So, time to just spam random asteroids around the star. Asteroid named Aura, okay, that's cool. Also, I know I said I'd only be using original stuff for this system, but I feel like this should be allowed just because, I've generated stuff before to use as, moons and stuff, so it makes sense I'm allowed to generate stuff for the asteroid belt. Also, do you guys really want to watch me make asteroids for the next several hours? I'd be willing to guess most of you don't. If you do, let me know. Maybe I'll do a live stream of that or something. That could be funny. Also, each second that passes in the system is around 100 years. Although it's decreasing because of the asteroids. I'm gonna switch... Oh, 6. Some of the asteroids have unique orbits. That's cool. I'm going to switch to trails just so that it's easier to see what's happening here. Alright, so here's the asteroid belt with orbits. It's not very large of an asteroid belt, but it works. Also, I really like this little dome here with all these asteroids. It makes it for a cool effect. I'm gonna disable orbits and trails for now, just because it makes it more clear, what's actually happening here. When you don't have to see this abomination. Trails actually works fine, but yeah. I wonder if I can remove the name from all that stuff using multi-select. Now, I'm gonna just get rid of all the names of all that stuff. Just reduce the visual clutter, you know? Ta-da! No more visual clutter, really. So, now that we have an asteroid belt, we need to add 6 more planets, and they're going to be gas giants. I'm telling you that now, they will be gas giants. There is no way that it would be incredibly difficult for a rocky planet to form here without it collecting enough hydrogen and helium and stuff to become a gas giant. Sorry, I don't know the actual physics behind this, but I'd say that's a humble 0.05% of a light year is far enough away for hydrogen to begin collecting. So yeah, we're going to be using a blank planet at 0.07 light years away as our first gas giant. Oh, accidentally put in an actual planet here. Well, step 1. I'm going to give it the name first this time. This one, since it's a gas giant that is very close, since this will probably be the warmest gas giant out of all of them, it shall be named I could make a Taco Bell joke here, but I don't think I will. You know what? It's really called the Chill Planet. This planet's cold, but not extremely cold. Ignore that. Ignore the average temperature that says it is in fact that cold. So, this thing takes nearly 500,000 years to orbit. Okay, so that's the chill planet down. Well, no, I'm gonna remake its atmosphere and all that. The issue is, because of how far away all this stuff is from like Stevenson 218, if I make this too massive, it will become the strongest attractor. So instead, I'm gonna make it smaller. So I'm gonna click slow down time. Oh, that's its rotation. Huh. So it orbits every half a day, and that's neat. So I'm gonna make it smaller. That should work. I think it would be cool if its rotation was a bit different. Tilt it to that. That seems cool. I'll add a bit of methane to the atmosphere. So trying to figure out how to actually change this. I'll just decrease the amount of silicate and increase the amount of helium. Why isn't it increasing? Oh. mass loss rate, huh? So if I add more, it'll just... Huh. So, it's more massive now. That was by accident, but let's see. Does it mess with the asteroids near it? No, it does not. Good. So, that one was pretty easy, to be honest. But, I mean, yeah, so, cool. It is going to be nice not having to mess around. Like, with rocky planets, you have to put in a lot of effort to actually, like, make them look the way you intended and, like, have the proper effect. Like, I had to cut out a solid 5 minutes from my previous video because I was just messing around with where to put the orbit. But with gas giants, you can't live on them anyway. Although apparently it says 30% Earth similarity. I don't even know. But yeah. So it's a lot easier to make them, in my opinion. Also, these asteroids are consistently 20% of a light, 25% of a light year away from Stevenson 218. So also I was wrong. It doesn't take this planet nearly 500,000 years to orbit. It takes it nearly like 50,000 years. These son of guns, it takes nearly around a fourth of a million years, give or take. 336 over 100 million years, I guess, would be the... You get the point. So... Huh. Normally the most massive object in the system would have a basically infinite tidal, Roche lobe radius. Well, I hope that doesn't have any disasters later on. Anyway. So, Planet 6. We're going to use a blank planet for this one. And to keep it far away from the rest of the system, 0.2 light years away from the star, you will find this planet. Okay, so step 1. Add, actual mass to this thing. Alright. Time for planetscaping. Okay, so time to add a lot of hydrogen to it. Hopefully this will stay as a gas. Add some helium as well. I don't know why the helium symbol is like that, but... Okay, so... Okay, those are clouds. I was making sure they weren't like frozen puddles of hydrogen and helium. Alright, so... This is weird. Okay, well. You know what? A small gas giant could be kind of a cool concept, not gonna lie. Oh, I guess it... Oh, I see. Most of this is liquid. Okay, that's cool. No idea how this thing's average temperature is. Oh, it hasn't had time to cool off yet. Okay. Give this thing a few years. And it's 106. It's still cooling. Okay, that's cool. But this one will be called the Cold Planet. It's also very not... It's also very, like... It's not very dense at all, which is kind of cool. And, its orbital speed is 1.67 kilometers per second. So, the Cold Planet is definitely living up to its name. This next planet will be put around a tenth of a light year away from the Cold Planet and about a third of a light year away from Stevenson 218. And it shall be named the What would be a cool name for this? I know. Very, very funny joke there. Well, I have an idea. The Very Cold Planet. I know. Very, very funny. This thing's orbit takes... This one takes 414,000 years, so we're getting close to the 500,000 years mark, so that's cool. Also, if you want a fun thing to do while watching this video, count the number of times I say cool and it ends up accidentally being a pun. That'll be funny, I guess. Time for my favorite thing, planetscaping. Step 1, lots of helium, even though it'll all freeze. There's probably some sort of solution to that, but I don't want to accidentally make a star by accident. Now's the part where the oceans start to freeze. Half a moon mass. So these aren't really gas giants, more so liquid giants, because they're so far away from the star that they can end up freezing their own atmosphere. So they look like gas giants, but really they're just on the inside, they're pretty much entirely frozen. I guess actual gas giants are kind of like that, except these ones, the freezing, I don't know. I don't know if there's anything actually special about these, but whatever. I'll consider this a gas giant because it has a obviously thick atmosphere. but it's definitely starting to become more and more questionable because the solid interior is most of its mass. Okay. So that's 7 planets we have down. That's the same amount as in our solar system. Now, here's the thing though. This star is extremely large, so you'd have to imagine it would come from a stellar nebula with a lot of hydrogen, which would mean there'd be other stars nearby. So we're going to be putting in a second star that orbits this star and has its own system. It'll orbit at a distance of half a light year. And the star we use will be Polaris, the North Star. It's not as massive as Stevenson 218, but it is still 4 times the mass of the Sun. So it's only 10% as massive as Stevenson 218, but it's still giant. But now that I think back on it, it wouldn't work because it would pull Stevenson 218 around. So we need a star that's large enough to be able to hold a somewhat sustainable solar system, but not so massive that it would have way too much influence on Stevenson 218. Some of the Castor stars look like they'd be good for this. We're going to be doing Castor Gem BB, and it'll orbit at a distance of, let's say, half a light year. No need for micro adjustments, I'll just put it there. This is its strongest interactor, but even then I don't think it's really doing all that much. It's only half the mass of the Sun. Make sure that all of these are still orbiting Stevenson 218 and not Castor Gem BB. Alright, so this star will have its own solar system. This is my plan to make it actually to keep all these outer planets somewhat original. Some of them will be orbiting Castor Gem BB. Which will be renamed to... Ooh, I accidentally took a screenshot. But its new name shall be... what would be a funny name? Well, you know what? I think it will be called, drumroll please, the Star, because it's a star that orbits a star. Actually, no, that's stupid. You know, I have a really silly idea. No, I'm not. That's not a good idea. Never expected this to be one of the hardest part of actually making the system, the names, but both videos I've been struggling with them. I have a stupid idea. Ta-da! It's the very hot planet. So this is not going to be considered on the planets because I'm planning to put 3 objects in an orbit around it. These objects will be large moons instead of planets, however. But I will consider them planets because they'll all be more massive than Mercury. So Titan will orbit it at very close and be it shall now be known as and it's the fastest orbiting one, so it's the fast planet in air quotes. And I know it's not technically orbiting Stevenson 218, but I'd consider it a part of the system anyway. Next up will be our moon, which will be in the habitable zone, because that just seems fun. And, well, I'm going to do a bit of modifying on Titan a bit. Maybe it being in the system messed with its density, but I did not know Titan was almost half of Earth's radius in terms of size, but I'll move up the sea level a bit because that's something I haven't really messed around with ever. Didn't even know Titan had a sea, but cool. That's a lot of water in its atmosphere. I think I know what I did. I think that unless that's just there naturally, I don't know. Since its surface gravity is so low, I wonder if I could do something fun with that. This definitely won't be a planet I can put life on, but I think that since it's so close, it should probably have a magnetosphere. So it has a magnetosphere now. That way it probably won't, get blasted away into a pile of dust because it's, it is very close to a very hot planet. So, yeah. Next up, the moon. This will be the one that in this system that is habitable. Thanks to everyone's favorite tool, planetscaping. So, yeah. It's gonna take a while, but step 1. Add some liquid water. It'll sort of pool up in the craters, and that's pretty neat, so. Oh, wow, yeah, that looks sick. So instead of having large oceans like most planets do, it'll have a bunch of crater lakes. Oh, its life likelihood is going up. So that's neat. The surface gravity might cause some issues, but who knows? Also, it is getting cooked, so, as literally, one side is facing facing a star for a month, so that's not good. Alright. pretty sure that one of the biggest things stopping it from, habitability is it not having that much of an atmosphere. I don't want to give it too much of an atmosphere that ends up, cooking the entire planet, but alright, I'm gonna quick strip away some of the the oxygen in the atmosphere isn't the issue, it's the water in the atmosphere. Get rid of all that. I'm trying to get this planet to be somewhat livable. Or, I guess it's the moon, technically, but... Now the issue is that, the surface, the poles are pretty cold. I think I know how to fix that, though. I take its rotation, and I'm going to increase the obliquity so it's turning to face the star at the poles. This helped balance the climate of the whole planet, so now there's only a few hot regions. Neat. Well, now I can actually add some more liquid water, I'd say. Great. It's happening again. Luckily, if obliquity can do all that, then what if I just set it to be really high, so the equator where it's facing, what if I set it to be 45? That way no area is getting cooked more than anything else in theory. Oh, it's kind of working. And it's been going on for a few years, so it's pretty stable, I'd say. So yeah, it's getting slowly warmer, but it's reached the energy in, energy out equality, so I think this is about the most it'll go. It is pretty warm here, so it wouldn't be a great place to live, but life could live there, as you can see. So this shall be called the what should I call it? This whole area I didn't really add water to, but I think it's kind of cool to have a water hemisphere anyway, so. We'll call it the livable planet. Probably misspelled that, but whatever. Also, I'm so used to all these things not, so used to the rotation being slow that I'm not used to it being fast. So, that's neat. So yeah, that's the entire system. So honestly, I like it. You have the warm inner planets. You have some livable planets here, the cold planets here, and then you have an entire new system that's just as connected, but still connected. Oh wait. Oh, I only have 9 planets. Well, that's a problem that can be easily fixed. We're going to be using a completely random moon. Brennus, which is a very... it's pretty large. orbit. It has a pretty quick rotational period, so that's neat. It has a faster tangential speed at equator than the Earth by 4 times. This is a cool moon. As such, it shall be called the Interesting Planet. Because it's interesting, I know. Shocker. So for this one, I'm going to change up the visuals for fun. The surface. So you can edit the visual. Wait, no, hold on. So is it edit data? Elevation map 1. Yeah, and you can set it to look different, so enhance. This is what it looks like at the moment. But now I can go to the visuals and change it, because this one's interesting, but it kind of looks dull. It's kind of cool and mountainy, but it all looks pretty much the same. And that's because I'm using the Pluto elevation. Okay, the Earth elevation map on this looks pretty cool. You can still kind of see where everything is, but not really. I think it might be because this is upside down, but... like... I'm pretty sure this is North America, but it could just as easily be, like, Asia. Actually, I think it might be Asia. I don't know. No, that's... That's the mid-Atlantic range, I think. Yeah, this with the Earth map looks awesome. Like, you can identify where stuff is, but it's difficult. That's cool. Makes it even more interesting, so I'll take it. So, yeah. Now that's the system. So, I'm gonna. This will be available on Universe Sandbox as a simulation you can download. So, look for Stevenson 218 system. Description. This is the system I made on the channel games and other such things. I know, shameless self-plug, but yeah, so that's the system. I hope you enjoyed the video, so thanks for watching, and bye-bye.